Hi. There's a lot of things you can do with data as a business analyst, and not all of those things are really ethical. So I think it's time that we talk about business analytics and ethics. So at the heart of it is that we collect a whole lot of data, usually online data these days. Do you have informed consent? Like, have you given it? Have you actually looked at the terms of service that you're agreeing to when you even sign up for a normal website? Most of these, or a lot of these websites, their main source of income is collecting information about people who use their website for resale to other companies. So it's almost like they're basically just pulling you in just to sell your details. And if they can sell you some other products directly, hey, that's a bonus. But they're really information kind of harvesting machines. Do you know what you're giving up when you agree to sign up for these companies? Really, it's a matter of data privacy, and I think both of these cartoons kind of speak to that. Businesses collect tons of data. Some of it they use themselves. Some of it they sell to other companies, who then use it themselves. All of it with an eye towards making money. And there's a whole lot of money that can be made. But you should know that even if you agree to give your data to one company because you trust that company, maybe it's a good company, favorite company, so many of them resell that data to companies that you might have a real problem with, and they might be doing stuff that's kind of icky with your data. So you need to be aware of that. And as a business analyst, you can maybe put your foot down and say, we shouldn't be doing this with customer data. One of the things that the companies harvest is location data. So a whole lot of your apps on your phone track your location. And this helps with location-based marketing, so that if you happen to be in a particular neighborhood, then you might be more willing to go to a store that's in that neighborhood, and so they'll kind of try to send you targeted advertising. But location tracking is actually a whole lot more precise than that. I was talking with someone who manages a local retail store. This was, maybe 6 years ago or something like that. I was talking about all this stuff they can do, tracking your location in different streets. He looked at me like, dude, that's like 10 years ago. I track people in my store. And I'm like, what? He says, yeah, we have an app, and it gives coupons and discounts to people. And so as soon as they come into my store, they pull up the app to see what's on sale. He says, well, as soon as they do that, I know where they are in my store. I can track to see, like, how long did they stay by, the polo shirts. If they stayed by the polo shirts for a long time, it looks like they were looking for a polo shirt. If they walk away, the algorithm automatically sends them a small little coupon. Hey, by the way, polo shirts, they're off by an extra 1%. Did you know? So it's really kind of amazing what kind of data they can gather. Amazing what kind of data you'll be using as a business analyst. As a consumer, you should be aware that this is happening. They're tracking your location inside a store by measures of like feet. They know exactly what product you were looking at and for how long. That's pretty amazing, and also a little scary, quite a bit creepy. Algorithmic bias is kind of a different ethical idea. Here we've got this actually kind of infamous case where they were testing out facial recognition software, and a lot of video capture is low resolution. So they were trying to figure out a way that they could take a low resolution image and then use what they know about how faces work to interpolate, to kind of fill in the blanks between big pixels and make it kind of smaller, more granular image. So it's using an algorithm to fill in blanks in an original image with pixels taken from data. And so they fed this image on the left, which I hope you recognize. And what was spit out was the probabilistic, most accurate guess that the computer could come up with. and it is someone completely different. In fact, it's not former President Barack Obama, but it's someone of a completely different race. Like, this one is not the other. And this really speaks to the nature of algorithmic bias. It's not like the computer or the formulas, favors one race or the other, or, doesn't like black people. It's just a formula, and the formula is race agnostic. So how would the computer make this mistake and misattribute race, where, to our eyes, it's very obvious who the person is? The idea is that whenever you're training your algorithms, you're going to use as much data as possible, right? So tens of thousands, if not millions of images of people's faces, so that it can reconstruct what it thinks is in between the pixels. Now, one of the issues is if your data set is unbalanced, and let's suppose that the data set included, the 90% of the data set was filled with white faces, then probabilistically the pixels in between the pixels are white as well. And so the computer's just dealing with the data that it has. And there's nothing, inherently wrong with the data, except that it isn't representative of what we're trying to do. And so the data's bias in this sense, biased in the sense that it has more white faces than black faces, turns up biasing the resulting formulas. And so what this means is basically you have garbage in and garbage out. Your formulas, your algorithms can only do as well as the data that goes into it. And so not only could you be making a social faux pas like this, but you could actually end up offending a whole lot of people, offending your customer base, or like, not just like not making money because you pitched the wrong products to people, but you could seriously cause your firm some real harm socially, and you could lose a whole lot of potential customers because this stuff isn't really cool, right? So it's fine with just, let's say, an image. At the end of the day, who cares if you interpolated pixels wrong? Not that it's good, but it gets worse, is what I'm trying to say. So criminal justice is, I think, an amazing example of algorithmic bias and the real problems that it can create. So imagine that you're trying to construct an algorithm that predicts whether someone could be convicted of a crime. Maybe as an attorney or as the state's attorney general or something like that, the prosecutor, you're trying to figure out whether it's worth your effort to prosecute a particular case or if you want to settle. So what do? You say, well, I need to know, I need to look at the data. Which cases get prosecuted more? Or let's say you're police and you want to know, who's a likely suspect. Well, let's look at people that have been convicted of similar crimes, and that'll help us narrow down our suspect pool. But here's where unbalanced data sets and algorithmic bias really comes in. How were those data constructed? If, for example, you had biased police, racist police, that only, would arrest black people, or biased prosecutors who would only prosecute black people, then according to your data, black people look guilty and are prosecutable. And so your algorithm would spit out a whole list of black suspects who should be prosecuted when that wasn't the case. It was basically perpetuating bias from these other sources. So again, it's not like you set out to create a biased product or a biased algorithm, but the algorithm feeds on data. And if a racist process creates that data, what you're doing is you're solidifying, you're entrenching that data into a supposedly objective formula. And then it's really hard to get rid of. So it's really like systemic bias at the algorithmic level, which is like, whoa. And this does happen, and there are cases of this. This is about as bad as algorithmic bias gets. Slightly, but only slightly less horrifying is mortgage loan applications. This was one of the first cases of really using algorithms well. So banks used to have to review an application for a mortgage or a loan by hand. And they'd have to figure out, is this person likely to pay me back? So a credit score goes a long way towards answering that. What's this person's income? What's their history of debt? Is their history, do they pay back their debt? Those are kind of some useful things. Now, banks said, I would like to use as much information as humanly possible to see whether someone is a good mortgage loan recipient. Okay, now let's think about the data that goes into this algorithm. If it happens to be the case that the original loan origination officers, the people who years ago were making these loans, if they determined that a certain class of people were a bad bet, then years later, the algorithms that feed off of that data would reflect that. And so this is yet another way of having a supposedly objective algorithm perpetuating a bias from years ago when the data were collected. And I'll leave you with one more case of algorithmic bias. HR. So maybe, let's say you're working in HR and you're trying to figure out which employees should be promoted. You could look at every individual as a unique person, which would be great, but it's also very costly. And you think to yourself, well, let's just, have a computer help us out here, an algorithm. Which people tended to be promoted before? Which people got raises? Which people did well in their positions? And then let's score existing employees as being more likely to succeed based on the similarity with those characteristics of the earlier employees. All right, now imagine that years ago, or maybe even the other day, you're at a company and that company has a history of only promoting or only supporting and encouraging a certain group of people and not promoting other groups of people. Well, in the data, it would look like this first group, they seem to rise really quickly in the company. This other group, not so much. They seem to not get promotions, not do their job very well, all because they hadn't been supported. But now that data, that history gets fed into the algorithm. And so as a very innocent HR person, you run your algorithm and it says, all right, this person likely to succeed. This other person, historically, based on the data, not likely to succeed. Well, I want to promote the successful person and not the unsuccessful person. And now what have we done? Perpetuate bias. Right? So if you have biased data, the only thing those algorithms can spit out is a biased recommendation. And I think that's very dangerous and completely unethical. And it's something that you need to be aware of. There's other issues with analytics, of data science. Facial recognition. On the one hand, it's, Facebook, and you post or whatever social media, you post a picture and it looks at the picture and goes, oh, this is your friend Stu. Do you want to tag Stu? Incidentally, what you're doing when you're tagging your friend Stu on the picture is you're increasing the website's database of pictures of Stu. And it'll help that company, Facebook or whoever, identify Stu in completely other pictures. Now, if it's just social media, who cares? But when governments get a hold of it, it can get really kind of, not so good. So I've got some pictures of the protests in Hong Kong from just a couple of years ago. The Chinese government is at the forefront of facial recognition technology. Right? They've spent billions on this, and there are cameras everywhere throughout China and HongOng. And the government keeps track of every single person on the street, and they know where they are, and they know who they are. But what that means is if you're doing something the government doesn't like protesting, like they were in Hong Kong, they know who you were, they know you're at the protest, and they're going to come knocking on your door and put you in jail, or maybe disappear you. So that explains why in the protest in the second picture on the right, all of the protesters have umbrellas. It wasn't raining, it wasn't even that sunny. What they're doing is they're hiding their faces so that the cameras can't spot them. So on the one hand, you've got this great tool with, digital data, with facial data, and you can do some cool things with it. But like with any tool, you can also do really nasty things with it. And it's one more thing that you need to be aware of. Finally, I'll leave you with this story about Forbes. And there's a reading about this quite famous case. And the idea was that Target was trying to figure out how to target potential consumers. So they kept track of all of their consumers' purchases. And what they realized is that, by the way, whenever you sign up for a rewards program or even pay by credit card, they know who you are, right? You volunteered that information, and they keep an account of all of the things that you've bought. And what they noticed when they went back over this data is that people bought certain items first, like a month or 2 or 3 or 4, or maybe even more, before they started buying tons of diapers, tons of baby food, and whatever. So Forbes's data analysts and their business analysts basically said, okay, we have now figured out a way where we can identify who's likely to become a mom real soon. So if we know you're going to be a mom, let's send you coupons about like car seats, baby strollers, things like that, because you need to prepare. And Target would like to be the ones that sell you those products that help you prepare. And by the way, Target did amazingly well with this program. Their sales went through the roof, especially in the new parent kind of market. But there's a privacy issue here. So Target started sending out these coupons and flyers to people, and they sent it to this teenage girl who was pregnant. And the dad was livid, and he stormed into Target, and he raised hell. Why would you presume my teenage daughter is pregnant, and yada yada. And he raised hell. And then he went home, and he said, "Can you believe this?" And she said, "Well, Dad, I actually have something to tell you." And so basically, Forbes told this girl's dad that she was pregnant before she had a chance to tell her dad that she was pregnant, which is pretty damn big invasion of privacy. So Target has kind of changed its ways a little bit. It has changed how it sends out the coupons and stuff to ensure privacy. But the idea that Target could make a whole lot of money by targeting consumers, that part hasn't gone away. It's just that now they're trying to do it a little bit more ethically and by respecting people's privacy a bit more. I encourage you to read that article. There's just a few page article on the details on this case and what Target has done to kind of mitigate future damage. These are the kinds of issues that as an analyst you need to be aware of, or as a manager who uses data as an input into your own decision making. Maybe you're not a data analyst, but just a manager. You really should think about the ethical consequences about your actions to your customers, or to the society as a whole. So as a student at a ethical university, I hope you think about these things deeply and keep them with you into your future career. So with that, I'll let you go. Thank you for your attention on this matter, and I will see you later.